The integration of autonomous vehicles, AVs, into specific sectors is already underway, with many industries experimenting with or preparing for the widespread use of self-driving technology. Autonomous vehicles have the potential to dramatically change the way goods and people are transported, enhancing efficiency, reducing costs, and improving safety. Here's a breakdown of how AVs are being applied across various sectors. 1. Autonomous ride-hailing and passenger transport. Current state. Companies like Waymo, Cruise, Aurora, and Tesla are at the forefront of developing autonomous ride-hailing services. In cities like Phoenix, Arizona, Waymo has already rolled out self-driving taxis with no safety driver in the car, although this is limited to certain areas and conditions. Future impact: shared mobility. As AVs become more reliable, the model of personal car ownership may shift towards shared ride-hailing services. People may opt to use autonomous taxis for everyday travel, significantly reducing the number of privately owned vehicles on the road and leading to fewer traffic jams and lower emissions. Cost reduction. Autonomous ride-hailing could lower the cost of transportation by removing the need for human drivers and improving fleet management efficiency. These AV fleets could be on-demand, 24/7, and easily accessible through apps, offering a more convenient and potentially cheaper alternative to traditional taxis or public transit. Accessibility. AVs could increase mobility for people with disabilities, the elderly, and those unable to drive. By providing a more accessible and personalized transportation option, autonomous ride-hailing could greatly improve quality of life for underserved communities. 2. Autonomous freight and logistics. Current state. Self-driving technology is being tested and deployed in the trucking industry by companies like Too Simple, Embark, and Kodiak Robotics, which are developing autonomous freight solutions. Long-haul trucking is one of the most promising use cases for AVS because it involves repetitive, long-distance routes with minimal interaction with pedestrians and other vehicles. Future impact: reduced costs and increased efficiency. Autonomous trucks can work longer hours than human drivers and don't need breaks, sleep, or time off, which could significantly lower shipping costs. They also promise to optimize driving patterns, reducing fuel consumption, and improving logistics efficiency. Addressing truck driver shortage. The trucking industry is facing a labor shortage, and autonomous trucks could help fill that gap. However, this will likely lead to job displacement for long-haul truck drivers, though new roles will emerge in AV maintenance, fleet management, and logistics optimization. Last-mile delivery. While autonomous trucks will revolutionize long-haul transportation, the last-mile delivery, getting goods from a distribution center to consumers, is still a challenge. Autonomous delivery vehicles, including electric delivery drones and robotic ground vehicles, could take over this final stage of logistics. 3. Autonomous delivery services. Current state. The autonomous delivery market is already experiencing rapid growth, with companies like Neuro, Starship Technologies, and Amazon testing autonomous delivery robots and small vehicles. These robots are being used to transport packages, groceries, and even meals to customers. Future impact: increased speed and lower costs. With autonomous delivery, goods can be delivered more quickly and cost-effectively than with traditional delivery trucks. AVs can travel in congested urban areas without the need for parking, reducing delays and cutting costs for companies. On-demand local deliveries. As demand for same-day and on-demand delivery services increases, autonomous vehicles will enable businesses to meet this need with fleets of autonomous vans or drones, creating new customer expectations and experiences. Impact on traditional delivery models. Major logistics companies like UPS, FedEx, and DHL are also experimenting with autonomous delivery solutions, which could reshape the competitive landscape for traditional delivery services. 4. Autonomous public transportation current state. Many cities and transportation agencies are testing autonomous buses, shuttles, and trams for public transportation. Companies like Navia, EasyMile, and Local Motors have developed autonomous shuttles that operate on fixed routes, such as urban centres, campuses, and business districts. Future impact: on-demand public transport. AVs could enhance the flexibility of public transportation systems by offering on-demand or dynamic routes rather than rigid timetables. This could be especially beneficial in suburban or rural areas where fixed route bus service is limited or cost prohibitive. Reduced operational costs. Autonomous public transport could reduce the need for human drivers, lowering operational costs for municipalities and transit authorities. Additionally, self-driving buses and shuttles could reduce traffic congestion, especially during peak hours. Enhanced safety and accessibility. AVs could make public transportation safer by reducing human error, and their on-demand nature could make it more accessible to people with disabilities, the elderly, or those in underserved areas. 5. Autonomous construction vehicles. Current state. Autonomous technologies are being tested in the construction industry to improve efficiency and safety. Companies like Built Robotics and Caterpillar are developing self-driving construction equipment, including bulldozers, excavators, and trucks that can operate autonomously on construction sites. Future impact: increased efficiency. Autonomous construction vehicles can work 24/7, improving project timelines and reducing the need for human labor. These vehicles can be equipped with sensors and AI to safely navigate complex environments, handle heavy loads, and perform repetitive tasks. Safety and risk reduction. Construction sites are hazardous, and automation can help mitigate risks associated with manual labor. Autonomous vehicles can handle dangerous tasks, such as moving large amounts of material or working in high-risk areas, keeping human workers out of harm's way. Cost reduction. Over time, the widespread use of autonomous construction equipment could lead to significant cost savings by reducing labor costs, increasing productivity, and improving safety, thus reducing insurance premiums and liability claims. 6th, autonomous agricultural equipment. Current state. The agricultural sector is embracing automation to tackle labor shortages and improve efficiency. Companies like John Deere and Raven Industries are developing autonomous tractors, harvesters, and drones that can plant, fertilize, and harvest crops with minimal human intervention. Future impact: precision agriculture. Autonomous vehicles can be equipped with advanced sensors and AI to make real-time decisions about where and when to plant, water, and fertilize, optimizing crop yields and minimizing waste. This could lead to a significant reduction in resource use, including water and fertilizers, and increase the sustainability of farming practices. 7. Autonomous emergency and rescue vehicles. Current state. Self-driving technology is also being tested in emergency response and rescue operations. Autonomous fire trucks, ambulances, and other emergency vehicles are being developed to respond to crises faster and more efficiently. Rescue operations in hazardous environments. Autonomous vehicles could be deployed in hazardous environments where it's too dangerous for human responders, such as during fires, hazardous material spills, or natural disasters. They could also be used to deliver supplies to stranded people or rescue individuals from dangerous locations. Telemedicine. Integration. In the case of autonomous ambulances, telemedicine technology could be integrated into the vehicle, allowing emergency medical staff to consult with doctors or specialists in real time during transport. 8. Autonomous military vehicles. Current state. The military is exploring autonomous vehicles for a variety of purposes, including logistics, reconnaissance, and combat. Autonomous drones, ground vehicles, and boats are being tested for deployment in military operations. Future impact: enhanced operational efficiency. Autonomous military vehicles could perform routine, repetitive tasks, such as logistics and surveillance, with minimal human oversight, allowing personnel to focus on higher-level strategic operations. Risk reduction. By deploying autonomous vehicles in dangerous combat or reconnaissance missions, the military can reduce the risk to human soldiers. Autonomous vehicles could be used for high-risk tasks such as mine clearance, reconnaissance, and supply drops. Cost reduction. Autonomous military systems could lower operational costs by increasing mission efficiency, reducing the need for human resources, and reducing maintenance requirements through more precise vehicle management. Conclusion: autonomous vehicles across sectors. The adoption of autonomous vehicles will be a multi-stage process, with different sectors adopting AVs at different paces depending on regulatory, technical, and market factors. As AVs continue to evolve, they will bring profound changes across sectors like ride-hailing, freight, public transport, construction, agriculture, and emergency services. While the road to full autonomy will present significant challenges, the potential benefits, such as cost savings, enhanced safety, environmental sustainability, and improved efficiency, make the future of AVs an exciting and transformative force across industries. Subscribe